Hello and welcome to the final installment of our three-part webinar series on GenAI-powered cloud modernization with DBShift. I'm Vaishnavi Galapuri, Director of Global Marketing at Systech, and your host for today's webcast. Over the last couple of months, we unveiled DBShift and delved deep into its functionality. So today we bring it to you live for you to see it in action, living and breathing. Systech's proprietary DBShift goes beyond migrating data from one warehouse to another. It's engineered to transform your entire data analytics ecosystem, streamlining and modernizing your operations with the power of GenAI. Joining us is Sunil Kumar Arjun Prasad, Vice President of Product Engineering at Systech. Sunil and his team, they've played a pivotal role in the architecture and development of DBShift, focusing on leveraging AI to enhance the automation and efficiency across the data processes. So welcome, Sunil. Happy to have you here. Before we begin, a few housekeeping notes. We've scheduled time for Q&A at the end of the presentation, so please type in your questions into the Q&A box in your control panel. Now let's dive into the future of cloud modernization with DBShift. Over to you, Sunil.
Thank you, Vaishnavi. And hello and welcome everybody for the live demo of generative AI-powered DBShift. In last two webinars, we have seen how our latest edition of DBShift is the right software for data warehouse modernization, which reduces the overall time and time by more than 90% compared to the manual or automation efforts that generally people have seen. This also saves the cost and time of modernization, and most importantly, de-risk the transformation for the enterprise. So today we will demonstrate the product live and display ease of transformation via DBShift. So let me quickly share my screen. So we start with obviously looking at what source from what source we're going to be transforming to what kind of a target. So if you look at that, right now for this particular demo, I'm going to be transferring data and objects and every associated things that is related to the data warehouse from Snowflake database to a Yellowbricks database. So I will begin with configuring my source and a target, and this is what will be the base for the entire DBShift suite that we have it in the product set. So let me just pick Snowflake here. I will take the credentials from the save thing. Let me test it. Yeah, looks good. I'll save it. And then I'll go ahead and choose my target. So here I'm taking it as a Yellowbrick, and I also have a connection saved for that. So I'll quickly test that as well, and then I'll save. So just after the configuration is done, what it is doing is that it's just going to be scanning the entire objects inventory within the source system, which is the Snowflake here. So it will start with, identifying all the objects that is there in the source. So what we have seen here is that there are totally 300 objects, which is there in Snowflake. Now the objects are like, there are 165 tables. There are 57 procedures are there. There are some external tables. There are some views are there, and then there are sequences and other objects. So this is just a kind of like a spectrum of what types of objects that we have it in a Snowflake source system. Now we'll go and do a little bit of an assessment of what does how complex are these objects are. So with our backend process, but before we go there, we'll just be looking at what are we dealing with here. So their total number of objects that we just saw is 300. It also says that there are conversions required for all these 300 objects. There might be some cases for the source and a target where you might not require any conversion, and for that you may get some numbers. But in this case, for the Snowflake to the Yellowbricks migration, we may have to do all the objects migration. That's what the indicative fact here is. The total number of objects are 300, but the conversion also required for every single object which is there in the source. Now let me go to the impact identification of what these objects are. So Are these objects all straightforward to do the migration, or there are some complex queries, or there are some, there are medium complexity. So complexity is one factor which will probably something that is needed for some of the manual transformation. So for example, there are some objects that maybe the large language model is not able, or the DBShift is not able to do the migration. And I'll show you the exceptions are really very few. But even if there are some exceptions where you will be seeing some manual intervention is needed, so you may have to assess the complexity of it so that you can assign the right person and right sizing that you do it for the assessment of how much time it will take to do the migration. So that is why it's important to categorize the objects that you have just scanned, and how complex are they. So it's like either a high complexity, maybe there are some heavy transformations done over there, or there are some medium or the low complexity. And then finally, we look at, object, inventories by migration type. So what it does is that, it actually, looks at all the inventory totally that we have scanned, just now 300 that we scanned. And then it just spreads it over the complexity that we just talked about. So there are low, medium, and a high. What you can see here is that as the longest bar is that out of 300 objects that we just scanned, 270 objects will be migrated via this DBShift automatically. So this is a good indicative number, but what it says that there are still some delta. There are some like 30 odd scripts which might require some level of manual intervention, and that's what has been spread based on the complexity. Now, whatever we have categorized here at 270, even though we have categorized as just a low complexity, but having the fact that since it's been done by an AI model, even of the higher complexity scripts or the objects are being observed, given the fact that AI doesn't really care for more of a high and a low, because once it's trained, it will probably be able to do the migration automatically for even high complexity, equally as it does it for the low complexity model. So this actually give a kind of like an indicator, or kind of like give you an idea about how much how many objects will be automatically be done and migrated via this tool. We'll do a quick evaluate to look at the roadmap, or how much time is required for doing this migration. We have like our own assessment methods based on whatever we have seen. But we have also saw that there's something called automation score, which has been identified based on the object scan that we have just seen. Now here in this case, it's really very high. It's 9. It's actually on a grade of 1 to 10. So it's 9. That means like, most of the object that we have scanned will be migrated by this DBShift utility itself. And it says that it will be taking 4 weeks of time. Now, 4 weeks of time, giving a consideration that we have seen, there were 30 scripts that might be required some level of manual intervention. So you may have to, split that with some, manual effort, and that probably will stretch up a little bit of a week's time here. But ideally, in a case of more than 9 or 9.5, you may be looking at like, 2 or 3 weeks of conversion efforts. And then 2 weeks of testing and training. Now, given the fact that DBShift has really robust mechanism to do the validation as well, which has really been we have tested it to the perfection. But still, as philosophy of Systech, we do not want to leave anything unturned. So even if we rely on AI a lot, but we do have a mechanism to do a parallel testing on each object that gets migrated by the utility by having a scanning done by somebody supervisedly look at it. So that's pretty much what it says, that you may have to do some level of testing as well. But overall, if you look at that, right, what we have seen here is that the migration, which you generally used to take like months or probably years, is now getting done in a kind of like 3 or 4 weeks. So that's the power of DB6, powered by generative AI, which we are bringing into the table. Now let's go to the migrate part of it. That's the the core of this overall engine that we have. Now, before I go there, I wanted to show you that what objects that we have it in the Snowflake. So if you look at that, I would probably be taking this database, for example, and I will be looking at the tables that I have. I have like department and employee are the tables that probably I'll be pulling up for this. And there are some views that we have it here. So I'll also show you our yellow bricks setup, so that it's just kind of like this. So to show you how does it, what are the objects that we have it, and what objects that we'll be bringing up for this demonstration. So let me quickly connect to the yellow brick. So till the time it gets okay, it's now connected. So I'll expand, and here is my database. In fact, this is my target database. That's where I want my all objects from Snowflake to be transferred here. So I'll go here. Just a moment. Yeah. So here, if I look at the tables and the view, there's no views available right now, but there are some couple of tables. But there are the tables that I'm talking about, the department and the employees is something which is not here. So let me now go to the migrate module, and I will do that migration from the database. So here I will pick up the data, which or the database which I wanted to pull the data from, or the objects from. So it's trying to load the objects that is there in that particular database from Snowflake. Now I can see that there are some tables like department, employee, and that's exactly what I'm interested in right now. So I'll pick up department and employee, and I'll pick up all the views. I want all the views to be out here. Okay, so this is out here. Now, just give me a moment. So here, after selecting the objects, I just hit migrate object. So now it is automatically started scanning the DDLs and the definition of these views from Snowflake. And it is trying to generate the corresponding DDLs and this view create script for the yellow bricks. So it has taken the DDLs from the Snowflake, and it's trying to generate the corresponding DDLs and the DMLs or the view queries for the yellow bricks. So let's go and let's give it some minute, because it's trying to generate these things. So it has done for the tables. It did one for the view as well. So just give me one more minute. Things should be done pretty quick. So now that's let me just let's complete it, and I'll highlight a couple of important factors here that how does it differentiate from if you're doing something manually. So if you look at that, all the objects that I picked up here has been migrated in the target. So let me quickly go to the yellow bricks and try to see if I can refresh and check all these things are out here or not. So by the time it gets connected, things get connected, yeah. So I'll go to the DBShift migrate database. So you see all the views has already been came up in the yellow bricks. So that's exactly, and let me just open up this view to see if I can show you the create of it. Okay, and let's compare these conversions. So that's important, and I'll show you the exact. Yeah, so let's compare it with what we have it in Snowflake. So if I can just look at the same view in Snowflake, I can see this is a script that has been there. Now, you can check on the differences that it has automatically been taken care of. For example, if I can see here, there's something called IFF, okay, and it has something called coalesce. And IFF has been automatically been converted as a case when statement. So if you look, for some of the automation that you might have seen before, it might probably be kind of like a find and replace utility where it just goes and looks at for a keyword and try to replace those things. So it's entirely different from that aspect of it. What it is doing here is that it understands this query. The model is actually understanding this query entirely, because it all automatically it's already having a kind of like a learning of Snowflake, and it tries to generate the yellow brick query like this, and that it has automatically generated the query, and now it has even created this view for the whole process. So it makes this overall process so easier. So you just hit a couple of buttons and you're almost done. Now I can go to the data migrate part of it. So the tables that I have migrated, I probably would like to fill in the rows from Snowflake to yellow bricks straight away, because it doesn't actually make sense to do the data transfer for the views. So for the tables, I'm just going to be hitting that let's transfer these two tables to the yellow bricks as well. So we saw the tables were actually got created, but these were just the definition of the table right now. But now it's actually transferring the data as well to those tables. So it'll take a couple of minutes again. So what it is in fact doing is that it's trying to create a tunnel between both Snowflake and Yellowbrick. And since it has already found the objects in both the databases, it is able to push in the data from the source and to the target so it both succeeded. So now either these two tables are loaded now. So next module is validate. So it's more important to, just give me one moment. So now that these two tables are already migrated, I'll pick up these two tables. And now I can pick what kind of validation that I would like to do. So here, let me just pick up all the types of validation that we have. I'll just pick like 4 different types of validation that we could do. And then I can just hit the validate button. Now here, one more important thing I want to highlight is that, if you look at that, if manual testing has been done here, every object that you are trying to migrate, you will have to write up all these test scripts manually. And then it has to be fired on both the source and a target. And then you will look at the exception, look at the reports from both the source and a target databases. And then you will look at the reports, look at the results, and then try to match if it is matching or not. If it doesn't, actually, you go for multiple iterations. What is happening here is that it's actually generating the test scripts dynamically for both the tables in both the databases for those query which is respective to these two source and a target. And it is executing it, and it's even probably bringing up those results, and then it is trying to match these two things. So this is actually our agentic framework that we have it at the back end of this product, where the agents does all these works at the background using this AI model that we have. So given some time, it probably would be able to do all these level of testing for these two tables, and it should be able to produce the results. So just give me a few more seconds. Okay. So by the time it comes, probably maybe I'll just see if I can quickly bring up that. Let me just quickly try this. Yeah, so it has succeeded already. So you can also see the kind of like a number of rows that has been there in the row count, and the stratification is actually more of like, doing an aggregation kind of testing. Random check is looking at random records and from both the source and a target and comparing cell by cell, null checks and things like that. So we have already validated the table that we have migrated, and now it's going to be the time to. So this is all the objects that we have scanned from the database. Now let's look at the convert part of it. Now convert is a very interesting place where you will be able to do migration for even the objects that is there embedded in some level of ETL tool. Like for example, if there is an ETL tool like Informatica and you have some source query source override or SQL override, you have those query out there in your, maybe you can bring up those queries from those Informatica mapping, and still you do want to do a migration for that as well. So I have taken few of those examples of the queries from the source, and I will be able to, quickly, I'm just put it in an Excel sheet, and I am just bringing out here. So these are the queries that I have picked up from the Informatica mapping, which was pretty much pointing into the Snowflake. Now, what I would like to do is that, I would like to, look at these, migrate these queries as well. So I have an option to, go ahead and pick up all the, I want to just do all the migration here, and I'll just hit convert to yellow bricks. So what it is doing is that it's generating again back for all these queries, which is actually a bigger query, and I'll show you what are these queries for some after its conversion is done. So it's automatically doing a conversion for the target query, which is like based on the Snowflake, it's converting it to the yellow bricks. And it's succeeding also for that. Let me just complete it for other aspect as well. So yeah, so it's almost done. And from here, once it is done, I will be able to quickly test it out. So also in the yellow bricks. So here, if you look at that, right? So I have already converted all the SQLs which was there embedded in maybe Informatica tool or maybe any ETL tool from source to target. I can also quickly test it in the yellow bricks. So it's not just the conversion, but it's also testing that it is coming syntactically correct or not, if there is any issues with this conversion or not. But hopefully everything, I think that this here you can see everything is succeeding. That means that everything has already been converted and executed into your yellow bricks. So we can say that it's already passed the conversion part of it. Now let's look at these queries and see what are these queries and how the conversion is being done. So I can quickly download it, and I can just Let me show you a couple of the examples here. Like, for example, if I can show you this. So if you look at that, right, this query has, this is the Snowflake query, and it has something called null if 0 and, timestamp, diff, day name, and cast. Now, there is nothing called null if 0 already there in Yellowbrick. So what it has done is it automatically taken that particular statement and it is doing a case when statement for that. It's like, it's rewriting that whole query in a different way. Likewise, if you look at that, it is there's another query. So IFF, there's a different corresponding syntax dialect for SQL for Yellowbricks is out there for IFF in Snowflake. So it's IIF. There are some other differentiation, like, if you look at that, there's something called, rtrim length and things like that. So just doing a multiple nesting of the functions to achieve the similar kind of functionality. So what I'm just bringing up here is that, if you look at that, if you might have done these conversions manually, you may have to go for these and doing it like, one by one, and you probably have to go for multiple iterations to get the syntax right and then the functionality right and things like that. What is happening here with the tool is that it's all getting done. The migration is done automatically because we have trained the model with exactly exhaustive number of examples. So it is able to understand the constructs of both SQL, Snowflake, and Yellowbrick. And then we can go for data validation. We can just quickly do it. But I would just want to quickly go to the connect part of it and want to highlight, a few things here. Connect is another interesting piece of a module that we have brought it here. Now, what we do is like, sometimes you might have some of the scripts or probably a legacy code that you have written. Maybe in a Python script, you have some code embedded in there, like some SQL embedded in between a big Python script. Or maybe there's a reporting XML that you might have. There is just some custom calculation that you might have done. So it's important to, carefully look at those places where you have a SQL. So we have a concept of something called precision, migration, precision generation. So I can show you what I mean by that. I'm just bringing you some of the scripts and I'll show you what do I mean by this. I'm just uploading a script, which is a folder, which is having a couple of scripts. So what it has two Python scripts, by the way. So I'll just do a quick migrate and I'll see if that migration is done. It's getting done. So it succeeded. So let me look at this script as well. Yes, it's done. So now in the source, if you look at that in the source, this is the Python script that got converted. And there are anything apart from the SQL, which is just this lines, which is there in the double quotes in the query, is not being touched by the generation. It has only looked at the place where there is a SQL statement, and it has just done the conversion for just that piece of code from Snowflake to Yellowbrick. And it didn't have touched anything else apart from, looking at finding it out the query and where the conversion should be done. So this is called precision, generation that we are doing it. And this is something which we have achieved for, looking at most of the, Python scripts or the XML scripts and things like that. This is something which is going to be coming very handy in case you have some scripts that is already there for some times and you do not want to touch anything else in the code because it's been legacy code. There are a lot of, work has gone in that, but you want to just look at the SQL part of it and do a conversion. So that actually brings to the closer of my demo today. Happy to look at any questions or any comments that you might have. Over to you, Vaishnavi.
All right, Sunil, that was great. Thank you for your insights. It's indeed exciting times for business modernization, enhancing efficiency, security, and innovation. Now we'll transition into our Q&A session. Please continue to put in your questions in the Q&A box, and we are eager to address them. We are receiving some great queries that tie directly into what Sunil just covered. I see a question come up regarding our compatibility with different data warehouses. It goes, my data warehouse is in Druid, which I didn't see in the source or target configuration. Do you have plans to add Druid as one of the sources for migration? Sunil, how do we approach adding new sources like Druid?
Yeah, we do have plans to add Druid. In case if there is any interest comes up, which you want to try it out, we can definitely speed up that process and bring it up in the product. So do connect with us with our marketing team and the sales team, and we will be able to get that faster. And we probably can look at your requirements in more details.
All right. Thanks, Sunil. We have another question regarding the tables and the complexity. The question goes, why you have tables with HML complexities based on what they would like to know.
So I guess I think there were some tables which was there with just a table, but then there are some auxiliary things comes up like constraints on the tables, and then there are some triggers which is already, there are a lot of things which is also attached to the tables, but there are some tables which is like external tables. So I think those are the kind of thing which has been categorized as high or medium. And maybe we can look at that specifically and check. But I think there are some conversions which actually doesn't go straight away as a DDL where you just change the data types. So it required some level of refactoring. So that's why the complexity has been termed as it is, as high, medium, and low.
All right. Hope that answered your question. Another question is, from C. Morlin. Estimation is given in weeks for how many people? What are the factors that impact that estimation? And they'd like to know what exactly is included as testing UAT by object type.
So it's a good question, by the way. So the thing is, if you look at our estimation is primarily based on the complexity score that, automation score that we achieve. So in the example that I was showing, it was it was reaching to the 9, and as I said, it's a range from 1 to 10. So 9 is really a good number. Now what I was coming up at is that there were like 300 scripts that we were having in the scan. And out of that, 270 was able to be getting migrated by this tool. So that's going to be very quick. It's not going to be taking more than a day's time to do that conversion. But then you have still 30 scripts. Okay, so based on the complexity of those 30 scripts or those 30 objects, we have a factoring mechanism to add how much time it will take to do that manual conversion. And that's how the weeks comes into that picture. So in detail, how many people will require to do that level of 30 migration also? I think we can give, we probably can, give a proper, assessment report on that as well. We have that report actually, I did not show that. But that comes with a pretty much detailed way of looking at exactly the timeline and how does this look like with along with our DBShift, what the manual effort will look like and how the timeline look like. So it will have the number of people also been added over there. So that's how it should be. So happy to connect with you and just show you that report if you would like to see it more. So we'll do that.
All right. I think, going back to the previous question on the tables, there is a clarification, only the tables and not the external tables. And, regarding the, the high, medium, and low complexity in the assessment. I'm sorry, they wanted to know why you have tables with high, medium, and low complexity, and what is it based on? There is, they're looking for more insights.
I actually not exactly follow the question, but is that not similar to the question that is already asked, like high, medium, low complexity? Yeah.
Yes. So
yeah.
I think they needed more clarity on that. I'm looking at the Q&A that's popping up, and they're looking for more details, I guess. There are questions here.
Okay. So for just to address that, in some more detail, I mean, we can have another session where I can talk about more about this. But the complexity that we have is actually a very much a computed, algorithm that we have created to find out the complexity of each object that will be migrated from source to target. And it depends upon what kind of a source that you pick and what kind of a target that you have, because for each databases there would be different kind of if the migration between the two picked up source and a target is pretty straightforward in terms of they follow the similar kind of a semantics of the SQL, then it will be having most of the objects falling into the lower complexity. So that's the algorithm that we have, and for every combination, the algorithm automatically puts up these complexity. So for example, like as I said, that there were some functions that needs to be rewritten. So complexity again doesn't actually really matters most for what tools can do the migration on, but complexity is something which is more of an indicative of the fact that if you have to do this manually, this is what you will end up doing it. High complexity, you might have to put up more time for the manual effort. It might probably require maybe 8 hours to 16 hours. If it is a low complexity, you might be able to do multiple, objects migration manually in a single day, 8 hours of a job. So that's how this complexity means. It doesn't really mean much for the DBShift tool utility as well, but overall the process, because we do not just ship the product, we also have the ability to augment it with any manual intervention that is needed. We augment that services as well. So that's where the complexity really means, with whatever is delta that comes up out of not being able to migrate it from the DBShift is where the complexity really matters. So
all right. Great. Moving on, we have a very pertinent question emerged about the outcomes of the assessment phase. So the question goes, what happens if the automation score is low in the assessment phase? So Sunil, could you walk us through how DBShift addresses this situation?
Ideally, there would not be in many cases where there will be a low assessment score, because whatever our philosophy of adding any source and a target combination in the DBShift product is that we do a very exhaustive training of the model. So what it means is that it would have already been seen a lot of examples of writing script for a given source to the target. So it has already seen many variety of examples, and as many varieties of examples has already been the model has seen, it will be able to do that migration pretty well. That's exactly was our understanding. But in case if there are some customers who might have some proprietary way of writing SQL, which is totally unique to them, that happens most of the some of the places where we have seen this whole different way of writing the customer, and you want to retain that level of writing the query in the target database as well. So we do have a incremental approach for our model, which we can do it like custom for just that particular customer, where we are going to be adding that additional level of skills or the way of doing the conversion within the model itself, so that you can do it for many cases. Ideally, I would like to minimize the number of scripts that is going to go into the manual bucket, so that if say for example in some cases my automation score goes fall below 6, then there are 40% of the script would still require manual intervention. That's a lot of effort, by the way. So we can probably look at those exceptions and probably do a incremental training on the model, so that for that customer's case, it probably will increase the number from maybe 6 to goes to like 8 or 9. Ideally, I would like to be in like 8 to 9 range.
All right. Thanks, Sunil. The other question that we have is, how special table attributes between databases are handled, like clustering in Snowflake?
There are some, so the clustering and all would probably require, I think, there would be some level of, as I said, that's exactly what comes into our end of the closing loop, where we do a little bit of a manual intervention over there. As of now, tool might not be able to do that thing. But I think, we probably would be able to augment that with some of the, manual intervention that we do it for the tables.
All right, we have a lot of questions. That's great. And so the next question is, when migrating the object, are dependent objects identified automatically? For example, if I want to migrate a nested view that involves multiple tables and views, will this move all interdependent view and tables automatically?
Yeah, so like for the view migration, I will obviously there's an understanding that your all related tables are being migrated first, and then you are migrating the view, because then you will be able to do the validation properly, and see the code migration will still happen even without the table migration, but it doesn't actually make sense, because then you will have to do the validation at the end of the migration. So it's an understanding that you will have to follow the sequence. First, you have to move all the tables, and all the tables that is out there in the view should have already been out there. So then only the view migration will happen, but the validation will also succeed in those kind of cases. So that the sequence should be followed.
All right. Thank you for the question, Karthik. Moving on, the next question is, what will happen if not all the queries can be converted without issues? IIF was converted to a case statement in the previous slide and not in the second. Any reason? They'd like to know.
So as I said, and that's exactly is the the model, that AI model that we have, it's actually very it's a it's a generative model that we have it as the backend of the product. And generative model is something which is, we can probably stick to, we have something called concept called temperature, and we can just stick it to the minimum for having a very much uniform way of doing every single, object constructs to exactly the same thing in the output. But since, we want to, have the model also adopt to the new level of changes, that exactly why some places you might see a different kind of a generation compared to the others. And in case if, but I think that, that's exactly where, the beauty of how this generative model works is how this that you have seen so far. It's not a very deterministic kind of an approach of, doing the migration. That's it's a generative way of doing a migration, and you might see some of the differences, and that's what we've seen in this case. But there is a possibility that, if the customer requires to be, have some level of standard to be maintained, and they want to be having one migration to be done exactly as the same, the other one, we have to tweak in a little bit of a triggers, like these switches, like temperature. As I said, one of those key factors is temperature, that I can put it to maybe a point, 1 or maybe close to 0, so that it will be very much deterministic. It will act like a deterministic generator, and then it will be pretty much sticking to the standard that the customer is posing.
All right. Thank you, Sunil. We have an interesting question about file formats. It goes, you showed SQL migration from a Python script. If I have a YAML file with SQL embedded, will DBShift help in migrating them to the target data warehouse as well? Could you explain how DBShift handles different file formats? Yeah.
Absolutely. Yeah. So that's what I said, like, currently I showed an example of Python script, but that's where it's actually a precision generation, where it doesn't trust the entire part of the entire script. It actually goes to the place where there's a SQL and finds out and do the generation. So yes, the other format of file, wherever the SQL part is out there embedded within it, there could be cases like, I can understand YAML might probably become in a reporting kind of, data, maybe exports. So, and they might have some SQL embedded in there. So yes, it is possible, and we will be able to do that level of, we should be able to handle, YAML as well out of the box.
Oh, great. We have another question. It goes, when an issue happens during the data migration, what kind of resolution that this product gives, or debug steps they'd like to know?
Yeah, so, looking at the nature of how this overall DBShift based on generative AI work, I probably can just give you kind of quick example of, say, it's as I said, like, the model has a really good understanding of the source and a target combination that we feature in the product. So as I said, like, it would be able to definitely be able, it's like, you may never be able to get into a place where there's no generation happen. Okay, and but our validation script always pick up, even there's a single comma missing, the syntax will definitely be throwing up an error. So I would assume that, there would be a very less exception cases where there's a failure coming up. But in case there's a failure coming up, you have really a good starting point where the most of the generation has already happened, and you start with that code rather than starting a code from scratch. So that's the benefit that you get. You probably would be able to, the code, the utility currently doesn't really do a debugging as such, because that's probably coming in the next phase of the product, where we are going to be having an agentic way of doing this migration as well, where there's a generator and there's a validator as well. The combination of the generator and a validator, do a to and fro and make sure that it's even debugs that. That's actually immediately coming up in another version of the product. We are still having that in the works. But as of now, the product debugging, code debugging is not supported, but it's going to be there, coming quite soon.
All right. This is one of the last questions. How do you assess the performance of the migrated SQL objects?
Well, it's if you look at the performance in case of how much time it takes to run, we have a log that gets generated, and it generates at both the source and a target. And apart from getting the results of the generated code in both source and a target, it also times the execution time, And it even reports in case if there is something going really high in the target generation. But to look at that aspect of it, it's like I have a code generated. Improving the performance of the code will always be something which requires to look at the code in a different aspect of it. It's not that just the code that has been given. There could be a possibility of having that code been run faster in a source, but it doesn't really run on a target. So we do have taken the consideration of doing this optimization, not just to looking at a direct translation of the code, by adding some of the best practices, and that is a part of our training program of this overall AI. But in case if we do get some exceptions like longer running queries in the target, we would have to look at that. If we look at that, if we find out a better way to do it, we'll have to do maybe incremental training onto the data on our model again to achieve a better score. So that's how I put it. But happy to look at those kind of cases and probably find out how can we fix those exceptions.
Okay, so thanks once again, Sunil. Folks, we are now over our scheduled time and we'll need to wrap up our live Q&A session. If you have further questions, so if you have any further questions or if we didn't get to address your query today, please don't hesitate to email us at marketing@systecusa.com. Or please scan the QR code that's displayed to connect with us directly. I'm happy to assist you with any information you need. Please take a moment to fill out the survey provided after this session. Thank you all for your participation today, and we look forward to your continued engagement for future SysTech events. Until next time, take care and have a great day. Thanks, guys.
Yeah, thank you all. Thank you. It was quite engaging and it was really interesting session. Thanks, Vaishnavi.
Thank you, Sunil.
Yeah.